Hello, everyone. My name is Sharan Raikar. I'm the product manager here at Chef Progress. I'm specifically responsible for Chef Compliance and Chef Cloud Security. And today we'll be speaking about how we achieve parallelism and scale in Chef Cloud Security. With me, I have Clinton and Nikita, who both are an integral part of Chef Engineering team. Clinton and Nikita, would you like to introduce yourself?
Sure, I'm Clinton Wolf. I'm an engineering manager with Chef. I've been with Progress Chef for over 5 years, and I work with the Chef Inspec and Cloud Resources teams.
Okay. First of all, welcome everyone to the Chef Conf. I'm Nikita Mathur. I'm senior software engineer in Chef Progress. I've been working here since last 1.5 years. I'm also one of the engineers in Chef Inspec. Hope you have fun.
Awesome. Thanks, Clinton. Thank you, Nikita. So with that, let's go through our agenda today. So we'll go through why scale and parallelism is so important in terms of cloud security. We'll also go through some of the components of a new Chef Inspec command that we have introduced to enable parallelism. We'll then have a demo of how this all works in the backend. And finally, we'll wrap up with the architecture or the driving force behind the parallelism. So let's understand a little bit about how the market and the industry around cloud is spanning today. The usage of cloud has been increasing rampantly. Based on a recent report by Flexera, enterprises are now increasingly using cloud services for a number of new use cases. They're increasingly using cloud for a number of new services as well. Even the dollar amount that is spent by an organization on cloud has been on the rise. As per the Flexera report, a very large number of enterprises today spend more than $60 million on cloud. So this is something that we see within our own Chef customers. One of our biggest customer, SAP, today uses Chef Cloud Security across more than 12,000 cloud accounts and also more than 13 million cloud resources. In 2019, SAP had around 1.8 million cloud resources, which grew to 3.5 million in 2020, and that grew to almost 7.5 million in Jan 2021. And in July last year, they were at 13 million cloud resources. So pretty much they doubled their usage of cloud each year for the past 3 years. And specifically in 2021, that growth rate was even higher. So the biggest challenge definitely for organizations today is how to keep up with the security posture when the usage of a cloud is increasing so phenomenally. What we see from the same Flexera report is also the fact that organizations are not only increasing the usage of cloud, but they also have adopted a multi-cloud strategy. And again, this is something that we see a lot among our own Chef customers, where we have seen a significant percentage of our customers adopting the multi-cloud approach. What is also seen from the Flexera report is that while multi-cloud strategy is pretty much a de facto standard for a large number of customers, the path that these organizations take to achieve multi-cloud kind of varies between different organizations, and most of the organizations are taking a combination of multiple private clouds and multiple public clouds to reach there. What is also interesting is the fact that while enterprises are now increasingly moving towards cloud, they're also moving a lot of sensitive data to the cloud. This may be consumer data or it may be corporate financial data, something very different from the past where organizations were very reluctant to move certain types of data into the public clouds. And while all this is happening, many organizations who adopt the cloud-first strategy are also creating a central cloud team or a center of excellence team that can provide centralized controls, tools, as well as the best practices for the rest of the organizations. Again, based on the Flexera report, we still see security to be one of the biggest challenge for both large as well as small enterprises. And this clearly manifests the fact that we are now seeing a central team that is responsible to maintain security across the organization. And this emphasizes more the fact that having a parallel and having a quicker way to assess your security posture is that much more important. So let's dig a bit deep into why speed matters so much in terms of security. The number one reason is the fact that the sooner the customers find out a problem, the sooner they get to audit their security posture, the faster they can respond and remediate it. And as enterprises achieve simultaneous and quick auditing and fix their cloud posture, they will also be able to grow and secure their environment and also scale their environment. One of the other advantage that we see from the parallelism and scale is the fact that customers get a consolidated real or a near real-time view of their environment at one go. And they can actually make investment decisions in terms of where to focus their critical resources on. Eventually, what all of this boils down is the fact that the faster that an organization becomes protected, the faster it can innovate, and the faster it will be able to concentrate more on its core business. So with this background in mind, let's look into how we enable parallelism and enable the faster execution, while at the same time we enable the scale in Chef Cloud Security. Now, at the back end of all of this concept is our new Chef Inspect command that we call as Chef Inspect Parallel, which enables you to execute multiple audit checks which target multiple systems. What you get is also a progress indicator, which tells users how far they have progressed in each of the audit checks that they are executing parallelly. It's also possible to integrate this command within a script, as well as use some of the input files, which probably list all your audit checks that you want to run. So it's a developer-friendly feature that you get here. Finally, you also get to execute either the same profile on different targets. You can also perform different audit checks on the same target, or you can run different parts of a profile in parallel. So you get a customized way of using the Chef Inspect Parallel command. And all of this enables you to get one near real-time insights. It enables you to scale. It also enables you to have a quick remediation, and finally make very speedy investment decisions in terms of where to concentrate your critical resources on. So let's now look into some of the examples where Chef Inspect Parallel command makes sense in terms of cloud security. For example, now using the Chef Inspect Parallel command, you can monitor all your cloud accounts parallelly across multiple clouds. Again, a scenario that we see more commonly used based on the Flexera report. You may also have millions of cloud resources being used within your environment. It can be S3 buckets, it can be firewalls or access keys. So any of the settings that you would want to check in each of these cloud resources or cloud services, you can accomplish that in real time. Scanning of registry images is another classical use case where you would like to have those checks run in parallel, and you will be able to then make a very informed decision of whether you want those images to be either deployed or you would want the images to be eliminated. And finally, there may be tons of network connections within your environment. So you would want to know the state of their posture or the security posture, and you would want to determine whether or where you would want to focus your remediation on. So that was a quick intro in terms of enabling parallelism and scale in Chef Cloud Security. With that, I'll hand over to Nikita to walk us through some of the internal details of the Chef Inspect Parallel command, and also follow up with a quick demo on how all of this works in the back end. Over to you, Nikita.
Thank you, Sharan. Okay, so just as Sharan mentioned, how cloud security is very important in today's world, and Chef has a solution to provide you the scale for it. That is through Inspect Parallel command. So Inspect has introduced this new command that is Inspect Parallel. By the name, it suggests that you can do things parallelly. That means you can have parallel executions of your compliance profile. So now there are two subcommands we're introducing here, which is Inspect Parallel Exec. And what it does is you can run your multiple compliance profiles at the same time, and the list thing, it generates a list of nodes for you, and that you can feed to Inspect Parallel Exec. Isn't that cool? Now let's run into the syntax for Inspect Parallel Exec. So the syntax for this goes like inspect parallel exec, and then the profile that you want to run on all your nodes, along with the options you provide with it. But there are two main options that comes with inspect parallel. That is option file and jobs. Now what option file option does? This is a new concept which we introduced with inspect parallel, and option file is a file which contains list of all the nodes that you want to target along with all the options that you want to run with. And it's a mandatory option. So if you don't provide the Z option, the inspect parallel will definitely throw you the error. We'll get more into the details for this, but before that, let's get into the another option. That is hyphen jobs. So the alias for this is -j. You can use both the things and it will work. You need to provide the number of processes that you want to run with the hyphen jobs option. For example, if you do hyphen jobs 5 or -j5, then it's going to run 5 processes at the same time, which means there are going to be 5 things which you're doing at the same time, like 5 security checks. By default, if you do not pass any value, it's going to pick the value from the number of cores of your system. If you have a 6-core system, it's going to pick 6 as a default value. There's no upper limit to this, and it totally depends on the capability of the system. So let's dive into a bit more around option file. So option file is the core of this command, inspect parallel. It, like I suggested, it is a list of nodes with all the options that you can run with this. It also supports shell, and it also supports text format. It also supports PowerShell format for the Windows. It also has ERB templating feature, which means you can run your Ruby code with the ERB syntax. You can also have comments added to your file in case you just want to know what every line is doing and you don't want to forget about this in the future. Each line is mandatorily supposed to have hyphen reporter option. That means whenever you execute something, you want to know what is the output for it. So you need to mention that reporter option along with the file so that you know what every run did. So let's see how we can configure option file here. So one of the example is you want to run inspect parallel on multiple targets. So the first target, you can see this is my Ubuntu machine. This is pointing to a local Vagrant node. So this is the Vagrant node it's pointing to, and this -t is one of the options of inspect exec. It's nothing new introducing, just the capability to provide you the list. Here you can also mention -f reporter, which is mandatory here. So I'm providing it the CLI reporter along with the file where I want this report to be printed. You can see on the next, I am pointing it to the EC2 instance. I've also provided it with the PEM file, and again, the reporter option, which is mandatory here. And then I'm also pointing it to one of the clouds account AWS, and another is the Azure. So you can point to multiple things at the same time, and you can run all of this with inspect parallel. Now, another way of configuring this is like if you want to run a separate profile on a separate node. So as you could see here, I'm running SSH baseline. So I'm starting my line with the profile name. Then I'm mentioning all the other options that you really run with inspect exec. So that is my target node and the reporter option. Even on the second and third line, you could see I'm running different profiles. Second, I'm running on EC2 instance, which is the Apache baseline. And third, I'm again running on a Vagrant node, which is running a Linux baseline profile. So these are some ways how you can configure your option file. And before diving into more, let's jump to one of the demos. So this is the syntax of how we actually go about it. Like I mentioned, inspect parallel exec. I'm going to run an AWS profile here. And this is my option file, multi-targets, and this is of text format. And I'm going to run 4 jobs here. So before I run this, let me show you how my option files look like. So this is my options file. I'm using 2 clouds account here. One is AWS and another is Azure. The first one, you can see the AWS one is pointing to 3 different regions, US East 2, West 1, West 2. And you can also see I have reporter manually mentioned here. I'm using CLI reporter, and it's going to print the output to the US East 2 and respectively the region files. On 11 line, you can see I'm running this on the Azure account, and I'm running an Azure profile there because I cannot run an AWS profile there. So this is what I'm going to target with parallel, 4 things at the same time. Even though they are mentioned sequentially, they don't run sequentially, they all run parallelly. You can also have other cloud accounts nodes here like GCP, Alibaba Cloud, or all the other providers that you want to use. And this will definitely provide you scale. So before I run this, I'll quickly run through the profile which we're going to run. So this is my AWS check, which is going to check for EC2 security. It's going to check for EC2 instance existence. All of these are security checks that I need to do on my AWS account, and it's going to check on different regions. And second, likewise, is an Azure profile, which is going to make some mandatory checks on my Azure account. All right, so since we're done with configuring our options file, and we've also looked at the profile we're going to run, let's try running parallel. Okay, so now let's start running parallel and see what happens. So there are 4 slots which are going to run here, since we had 4 things running in our options file. And these IDs are the process ID, since inspect parallel forks the process in the background. And you can see these 4 are starting up. It could take a while for each process if they're really slow. And inspect parallel can also be advantages here. If some of your processes are slow and some are faster, then they will run on their own speed. So the slot 2 is making progress. It's 100%, and it's already done. And so is slot 3. So the 3 slots are already done, and we are waiting for the 4th one. It's clearly the slowest of all the jobs here. And now, since all the slots are done, we can see what happened in the background. So when inspect parallel runs, it also creates logs in the background, and it also creates the reports when you're running it. So you can see here, there are 4 log files created here. And there are also some output files created here for each region and also the different accounts. So let's check out one of the log files first. So log files typically contain start time. It contains the arguments that we run with inspect parallel, and it contains the exit code and the time along with it. So you can figure out how much time it really took for one run. Like, for example, this run started at 22:13 and this got ended at 22:14. So it took around approximately to 1 minute. Then you can also see another log here. And this shows it got started at 22:13, 29 seconds, which means this also got started at the same second. So this all got started at the same time, which means they are running parallelly. Now there are arguments here, exit code here. There are also sometimes extra logs like warnings if there are any present in the system. So that will also be part of this log. So this is how logs get created in the background, so that if there is any kind of error or you need to debug something, what went wrong, you can debug it. Then there are these reporter files we can check out here. So basically I had a CLI reporter here. So it created a CLI report into a separate file, and this is the output for it. Okay, let's check out last for Azure as well. And it should have also created some output in the CLI reporter. Awesome. So this is how this creates output in inspect parallel, because you cannot really see output for everything on the screen at once, right? So yeah. So this is how you can actually scale up your cloud system, and this is how inspect parallel works. Let's get back to what are the different ways how you can configure inspect parallel's option file. Okay, so the third way of configuring option file is that we have provided this feature of using ERB with the PID term. What this thing does is, for example, in this, you can see that if your process ID is 123456 and you are using this here with the reporter, then it will create your reporter file with the process ID. Similarly, on the second line, you can see if your process ID is this, it will create your log file with this process ID. So that's one of the nitty-gritties we provide. The fourth way of configuring is if you have a shell file. So in the shell file, as you could see, we are trying to get the shell options file from the remote locations. And in this way, you can dynamically create your option file instead of actually creating one in your existing system. You can get it from another system if you have one. So these are some of the ways how you can configure option files. Now, there are some additional options here with inspect parallel, and that is --dry run. So what you can do with this is before running parallel, you can do a dry run, which will list you all the options which are going to run with inspect parallel. Now there is another option of -UI. So we saw on the screen there were 4 slots with the percentage statuses, right? But if you want status in terms of text, or if you don't want any status at all on the screen, you can choose the silent -UI option. Then last but not least, there's log path. Now we already saw that inspect parallel is creating log in the background. It's also creating a report of files. So if you want to change those log paths, you can use this option and you can provide the path which you think is suitable for your system. And this is some of the ways how you can configure inspect parallel exec and really provide scalability for your cloud security checks. So with this, I'll hand over to Clinton, who will proceed forward with inspect parallel list.
Hi. All right, so Inspect Parallel List was created to handle the problem of generating those option files when you have a known source of something and you wish to be able to iterate over it and target everything that's being listed there. So a good example of this is Amazon ECR's container registry. So you wish to list all of the images on there. So you would run inspect parallel list -r AWS ECR images. You'd list the repo under the parameter name, and you'd target which AWS region you're targeting. There's only one required option, resource or -r, that tells which parallel resource you wish to iterate over. There's support for only a few parallel or plural resources from the beginning, but we're adding more every week. And this is just a way for you to list targets for you to run using inspect parallel exec. Right. So the option resource specifies which resource to iterate over. Here in this case, I'm giving the example of listing AWS EC2 instances so that you could list all of the AWS instances, EC2 instances, and then perhaps SSH to them, for example. Internally, this thing generates a very small profile that will be that you'll connect, that it automatically connects to and lists all of the children resources of the plural resource that you provide. So that's why it's asking for a plural resource here. I'm sorry. The parameters option provides resource parameters to the plural resource that's been provided. In some cases, this is required, but in other cases, it isn't required. In the case of AWS EC2 instances, it's not required. You can provide a VPC here. In other instances, like AWS ECR images, you need to provide the repository name. So the query option, every plural resource has a where clause on it that tells you what to query. So using the query option, you're able to specify a query and narrow down exactly what it is you're searching for. So you might only search for certain EC2 instances that have a particular tag, for example, or that are running a particular operating system. Those are all things you can do using this. The target option specifies which the connection options for the initial connection to the place that you're listing the resources. This is used to connect to the infrastructure that contains the resource that will be listed. This could be a different target than is used to connect to the actual individual resources. Like in the case of EC2 instances, of course, you would connect to AWS to get the list of resources, and then you would connect to the host name of the EC2 instance to actually connect. All right, so here's Inspect Parallel Exec's architecture. The architecture of this is basically maintaining a job pool of processes that it uses to execute the options that it reads from the option file. So it reads the option file, and then for every list of options there, it constructs an invocation. And that invocation is then used to drive the execution of a process, and that process reports status back up to the main execution process, while also writing its output out to a specified file that you specify using the reporter option. So it maintains a fixed size job pool. Each process lives the length of time that it takes to execute the job that it had, and then it exits. And then we start a new process for the new job. And that's basically how Inspect Parallel Exec works. So Inspect Parallel List works differently. It generates a temporary profile that includes metadata. It includes generating a control for a plural resource. And then we attach a special formatter to the profile so that we'll generate only targets as output. And then we actually execute the query profile. And as we execute the query, every time that we encounter one of these child objects, we call the little formatter so that it executes a format or so that it generates a target string that will be generated as part of the target list. And then we just output the target list up to whatever called us. And that is how Inspect Parallel List works. Over to you, Sharon.
Sure. Thank you, Nikita, for that wonderful explanation on the components of Chef Inspect. Also helping us understand, what are the bridging aspects that make up the Chef Inspect parallel command. Thank you also for that wonderful demo. And thank you, Clinton, for that exciting insights into the world of parallelism and the architecture behind it. So that pretty much brings us to the end of the session today. What we did today was basically we went through an understanding of why parallelism and scale is so important in terms of cloud security, and what we have done at Chef to enable that through the Chef Inspect parallel command. We also went through an understanding of all the components that make up the Chef Inspect parallel command. We also gave you a quick demo into how this can play in a real world, by considering a few of the cloud accounts and the cloud aspects. And finally, we also went into the aspects around the architecture behind the Chef Inspect parallel command. That pretty much brings us to the end of the session today. And again, if you're looking for more details, more information around parallelism and how it enables scalability, we have a detailed GitHub documentation around it. We also have very detailed documentation around the Chef Inspect. We do have product pages, and we do also have data sheets and case studies. Specifically with respect to Chef Cloud Security, we have the product and solution pages, but apart from that, we've also built together a ton of resources around the data sheets and how cloud security works specifically in terms of environments such as Docker and Kubernetes. I hope this session was informative to all of you. And once again, thank you all for attending this session. And I thank you, Nikita and Clinton, for this wonderful session. Hope everyone is enjoying the Chef Conf. Have a good day, everyone.